Okay, we're looking at Chapter 8.1, Divide Fractions and Whole Numbers. And if you enjoyed multiplying fractions, I think dividing fractions is pretty easy, and you'll enjoy it too. We're going to start with some models, which I think seems to be pretty typical. We think about Mia, who walks 2 miles on a fitness trail. This is page 339. She stops to exercise every 1/5 mile. How many times does Mia stop to exercise? So she walks 2 miles, but every 1/5 of a mile she stops and she does push-ups or sit-ups or jumping jacks or something like that. So we're going to write a number line to model our problem. First, it's a 2-mile walk, and we're dividing it into 1/5 sections. So it's 2 divided by 1/5. I think that makes sense. And we go ahead and put a number line out. Maybe we'll change colors here, and we put okay, so this is 0. This is where she starts, and she goes 1 mile, and she goes 2 miles. And it suggests that if she's going to stop every 1/5 of a mile, that maybe we should cut this into fifths. So I need 5 sections, which is 1, 2, 3, 4, and a 5th section. So 1, 2, 3, 4, 5, and then I do the same thing. Notice that there's 4 little marks, but it makes 5 sections. And I'm going to do the same thing over here. 1, 2, 3, 4. Okay, so I've got 5 sections here with 4 marks. And what we need to do is we need to just count. Every time we see one of these, this is where she stops and she does push-ups. So how many times is she going to do that? So there, if we start here and we count 1, 2, 3, 4, 5, we know that there, since we cut it into 1/5, there are 5 sections in each mile. 1, 2, 3, 4, 5 is 5 more. So there's a total of 10 times that she stops to exercise. And so we really can see that 2 divided by 1/5 is equal to 10. And that feels weird because 10 got big. And we want you to understand, this is one of the things we're going to talk about a lot, is whenever you divide by the number 1, for instance, 2 divided by 1 is 2. But when you divide by something smaller than 1, it ends up getting bigger, like that. Okay, so we could count that out. We can actually show that it works by saying the opposite, 10 times 1/5, and find out if that equals 2. See, because 2 divided by 1/5 equals 10, so 10 times 1/5 should equal 2. And 10 times 1/5 is 10/5, right? And which is equal to 2 ones, which is equal to 2. We can see that that does work. Okay, that's example 1. Okay, so the second one, Roger has 2 yards of string. He cuts the string into pieces that are 1/3 yards long. So this is similar. We have 2, but we're dividing it into thirds. How many pieces of string does Roger have? So this suggests that we use 2 fraction strips. So remember, those kind of look like this. This counts for 1, and this counts for 2. Okay, so this is like 1, and this is 1 hole. So there's 2 holes. Then place enough 1/3 strips to fit exactly under the 2 holes. So we think about, well, a 1/3 strip. Let's change the color just so we can. Now we don't actually have fraction strips, but we want to think about the fact that fraction strips, if we use 1/3, it would take 3 of them, like that, lined up to make 1. So how many of them would it take lined up to make 2? So if we count those up, we see that we have 6. So there are 6 1/3 size pieces. And again, notice that when we divide by a number smaller than 1, our answer sort of grows. And we actually might notice that it grows by about the same amount that this denominator is. And we'll find out a little bit later that when we divide fractions, we actually can change it to a multiplication problem and multiply by the reciprocal. And we'll talk more about that later, but we turn over the 1/3, divide by 1/3, we multiply by 3/1. This is called a reciprocal. And we get 6/1. So really, whenever we have to do long division, or sorry, not long division, regular division of fractions, we change it into a multiplication problem. And so there's really only that one little step in solving it. But we need to focus on models for now. Okay, so it's important for you to see what we're doing there. And that's kind of how that's going to go. Okay, so the last little thing I want to do is we'll talk about this idea of dividing, and we'll start with something big that we can kind of see. 20 divided by 10 is 2. So 10 is a number that's much bigger than 1. And when we divide by a number bigger than 1, our answer, our quotient, gets small. We started with 20, we divided it by 10, and now we have 2. That's like saying if we had 20 candy bars and we share them with 10 people, everybody gets 2 candy bars. So this is a number bigger than 1. A divisor bigger than 1. Or greater than 1. Okay? If we try 20 divided by 1, we get 20 whenever it's equal to 1. Okay, whenever we divide by the number 1, it stays the same. But if we were to divide by 1/2, okay, so let's go back to our idea of 20 candy bars divided among 10 people. Everybody gets 2. If we have 20 candy bars and we divide them among 1 people, that one person gets all 20 of the candy bars. Okay, if we had 20 candy bars and we divided them amongst a half a person, that means a half a person would get candy bars, and the other half a person would also get 20 candy bars. Well, maybe that's kind of a little complicated to think about, but maybe if we thought, well, if we divided all of the 20 candy bars in half, how many pieces would we have? Well, we'd have 40 pieces. And so whenever you multiply, or when you divide by a number that's smaller than 1, that's less than 1, so this is a less than sign, less than 1, then your quotient gets bigger. And that's what I'm hoping that you guys will see. When we started with 20, and we talked about candy bars the whole time. We divided into 10 groups, 2 per group. When we divided in one group, there's 20 per group. When we divide it into a half a group or into half a person, then you get 40 pieces because you're cutting them all in half. And I know that's where I maybe started to lose some of you. But you can kind of see how it works. And then the reverse is true, and the reverse is what kind of helps us to prove it. The reverse would be where if we say 2 times 10 equals 20. So 20 divided by 10 is 2. 2 times 10 is 20. 20 divided by 1 is 20 because 20 times 1 is 20. And 20 divided by 1/2 is 40 because 40 times 1/2 is equal to 40 halves, which is equal to 20. And that shows how this works in reverse. Okay, that's all. You should be able to do your lesson now.